Good morning to everyone. Good morning. Okay. So before going to today's concept, as usual, so I'll be discussing about whatever we have discussed on Saturday. Can anyone tell me what and all we have discussed on Saturday? So Saturday, if you remember, we have discussed especially once again about 3.3 and 3.5, right? So 3.4 still it is pending. So don't worry, we have to cover that one. I am going to cover that one, 3.4. Now when I am talking about Saturday's class, so where we have discussed about D block elements, right? So where we have discussed about D block elements. Now all of you know features of D block elements, and very important point here is it is called as transition elements. It is called as transition elements. So that's where we have the D block elements, which are called as transition elements. Why they are called as transition elements? Yes, Shri Vidya, you are absolutely right. So why they are called as transition elements? That is because their location or their property in the location with respect to periodic table and properties which are intermediate between metals and non-metals, or I can tell that they are not metalloids, metals only, but since they are present between the metallic character and non-metallic elements, so therefore they are called as transition elements, right? So that is one of the feature of the D block elements, right? Now as we have discussed, already we have discussed this one, they will show multiple oxidation state. They will show multiple oxidation state, and already we have discussed that penultimate shell is going to be empty. Empty in the sense it will be partially filled, it has to be filled, right? So that's where we have the D block elements, where D subshell is going to get filled up, right? So Achyuta, yes, I will come to that, very good. So that's where we have the D block elements. What is the general electronic configuration? General electronic configuration will be n-1d. It will be 1 to 10. It will be 1 to 10 because D subshell can accommodate. Sir, okay, board is not visible. Now, whether it is visible? For all of you, board is visible? Because Achyuta has written board is not visible. For all of you, same problem? Means yes sir, in the sense it's not visible. Okay, fine. Now it's clear. Okay, fine. So that's why we have the multiple oxidation state. And when it comes to electronic configuration, yes, thank you. And when it comes to electronic configuration, general electronic configuration, n-1d 1 to 10, because D subshell can accommodate 10 electrons, right? So that's where we can see D subshell is getting filled up. Penultimate D subshell is getting filled up, right? 1 to 10. So now Ns it should be 0 to 2. It should be 0 to 2 because we have seen chromium and some of the examples where S subshell is not at all completely filled. Before that, D subshell was getting electrons, right? So that's what I wanted to tell. So therefore, general electronic configuration for transition elements will be this is the one, right? So which starts from period number It starts from period number 4 to 7. It will end up at 7. Period number 4 to 7. D block elements will be there. Right? So therefore, we can have 3D block when it comes to period number 4. So when it comes to period number 5, it will be 4D block. When it comes to period number 6, it will be 5D. When it comes to period number 7, it will be 6D. Right? So what I mean to tell here is, when I am talking about elements present in the period number 4, that's where 3D subshell is getting filled up. When it comes to 5, 4D subshell is getting filled up. And when it comes to period number 6, it is 5D. And when it comes to period 7, it will be 6D. Because all of us we know that when we are talking about period number 5, 6 or any of these, we are dealing with the outermost electron, where in those element outermost shell will be that particular period itself. That is, in period number 5, those elements outermost, it will be 5th energy level. Right? So therefore it will be 4D, n minus 1D. Due to that, it will be n minus 1D. All of you have understood? So that's where we have the D block elements, which we have discussed in the last class. Fine. Now we will come to the next one, which we had started with this one. That is F block elements. That is nothing but F block elements. Fine. So that's where we have the F block elements, which we have discussed. Right? Now, if you remember, F block elements, that is starts from, or that includes period number 6 and 7. Period number 6 and 7. These are the two periods which consist of F block elements, or those elements which are present in these two periods are called as F block elements. All of you have understood? So that's where we have the period number 6 and 7. Now, when I am talking about period number 6, it is 4F which is getting filled up. When I am talking about period number 6, it will be 4F which is going to get filled up. So when I am talking about period number 7, it will be 5F which is getting filled up. It will be 5F which will be getting filled up. Fine. So that's what I can tell that. Here in this case it will be n minus 2F, n minus 2F, n minus 1 it is related to D, n minus 2 it is related to F. So why? Because when I am talking about outermost energy level as 6, then 4F is getting filled up. When I am talking about outermost energy level as 7, then 5F is getting filled up. That's what we can see here. So once again, we will write some of the electronic configuration. Helium, neon, argon, xenon and radon. Right? Oh, krypton only I have one. So helium, neon, argon, krypton, xenon and radon. Then 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, even up to 7 we will write. So 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. So that's where electron will be filling up. So 3p, then 4s. After 4s it will be 3d, and after 5s it will be 4d, and after 6s it will be 4f, and after 7s it will be 5f. So that's what we can see. Right? So after 6th energy level, that is 6s, then comes the 4f. That's what I was telling, n minus 2. Then after 7s, then comes the 5f. That's for n minus 2, I was telling. Okay? So how many electrons F block, F subshell can accommodate? It will be how many electrons? Yes, 1 to 14. Yes, 14 electrons. So we can write it as n minus 2 F1 to 14. So due to F subshell which is getting filled up, they are called as F block elements. Due to the F subshell which is getting filled up, they are called as F block elements. Fine. So therefore, how many elements will be there? 14 elements. Yes, Sachita. So there will be presence of total 14 elements because 14 electrons can be accommodated. Right? So we have two series. One is lanthanoid series and another one is actinoid series. Lanthanoid and actinoid series. Now when it comes to lanthanoids, they comes after the lanthanum. Right? So when it comes to actinoid, they comes after the actinium. Right? That's where we have the lanthanoid series and actinoid series. So that's what we have discussed here. It will start from cerium 58. Now it will go up to lutetium. It will go up to lutetium. So when it comes to lutetium, add 14 to this. For 58, add 14. So it will be somewhere around 1 minute. Fine. That's what we have the elements. So next one. Next one is from thorium. From thorium it goes to lauresium. From thorium it will go to lauresium. Fine. So if I consider this one as 80. Oh, I have not included cerium, right? So here it can be 71. So 80. Then add 13 to this. Add 13 to this. Then it will become, why 13? Because I have not included actinium, and lanthanum. So therefore 58 to 71. That is cerium to lutetium, thorium to lauresium. Thorium to lauresium. So lauresium means atomic number will be how much? You should add 13. So it will be 103. It will be 103. Lauresium. Fine. So that's where we have the lanthanoid series which starts from cerium and it will ending up to lutetium, and actinoid series which starts from thorium and it will going up to lauresium. So they are called as F block elements. So why they are called as lanthanoid series? Because these elements, they are after the lanthanum. Why they are called as actinoid series? Because they are after the actinium. All of you have understood? So that's why I have included 13. That's why I have included 13. Why not 14? Because here I have not written lanthanum and here I have not written actinium. As it is in your textbook, I have written. Okay, na? So actually in F block, how many it should be there? 14 elements in each series. Because F subshell will be having 14 electrons. It can accommodate 14 electrons. Fine. So try to remember the first and last element. They can ask in competitive exams. Fine. Now, when it comes to D block, there was penultimate shell which was getting filled up. All of you will agree? When it comes to D block, penultimate shell was getting filled up. But now, since we are talking about a shell which is next to the penultimate, not upper higher energy, but lower one. So we are going much more deeper, right? Say for example, we will imagine we have a element, okay? So where this is the outermost energy level, and this is called as penultimate shell. This is called as penultimate shell. This is outermost shell or valence shell. Fine. Now in D block, penultimate shell was getting filled up, but if you observe here, it is much more inner energy level which is getting filled up when it comes to F block elements. Right? So therefore, they are called as inner transition elements. Therefore, they are called as inner transition elements. Why inner transition elements? Because unlike transition elements where penultimate shell was getting filled up, but here it is the shell which is much more inner to the penultimate shell which is getting filled up. So therefore, they are called as inner transition elements. Right? So we have two types of inner transition elements. One is 4F inner transition elements and another one is 5F inner transition elements. Which are those 4F inner transition elements? Lanthanide series. Which are those 5F inner transition elements? It will be actinide series. Fine, all of you have understood? So that's where we have the inner transition elements. Now, if you want to write the electronic configuration for cerium, can any one of you write electronic configuration for cerium 58? So which inert gas we can take? So here it is 2, then 10, then 18, then 36, then 54, then 86. Got my point? So 58, that means we can take the help of xenon. We can take the help of xenon, no doubt. When it comes to F block, either we should use xenon or radon. No other inert gas will be utilized. It will be either xenon or radon. So element which belongs to lanthanide series, we have to use xenon. The element which will belongs to actinide series, we have to use the radon. Yes, Ashish, you are right. So xenon we will be using. Leftover is 4 electrons. Now when I am telling xenon, it belongs to 1, 2, 3, 4, 5. So that means up to 5p6 it is done. Up to 5p6 it is done. Then after 5p we have 6s, 4f, 5d. Right? So we will write 6s, 4f. I think here only it will be done. So 2 electron in F S subshell and 2 electron in F subshell. So even you can make 4f come here, 6s can go outside. That is also fine. Because 6 is larger number. Fifth one, 5d, it does not having any electron because that many electrons are not there. That many electrons are not there. Yes, Ashish, absolutely correct. So that's where we have the 4f2, 6s2 as the outermost energy level. Why F2? That is because F1 will be coming when I am talking about lanthanum. F1 will come when I am talking about lanthanum because before that we have the lanthanum with 57. So before this we have the actinium with 79. Right? So that's where we have the elements. Fine? All of you have understood? So 6s2, 4f2. Okay? Now, if I want to write electronic configuration for lutetium, lutetium is 71. Naturally, as I told, lanthanide series, we can go with xenon only. Lanthanide series, we can go with the xenon only. Now 54 xenon, so 71 minus 54, how much it will be? 71 minus 54. So that means 7, 1. So we have to make the 17 electrons to get accommodated. 17 electrons. So what I will do is, same thing, it will come 6s, 4f, 5d. So 17 electrons, right? So 6s2, right? Then we have to have 14. 16 it happened. So 14 plus 2, 16. Then another one, 5d1. Another one will be 5d1. Right? So that's where we have the electronic configuration. That is 4f14, 5d1, 6s2. Please remember, we are not talking about the D block. We are talking about the elements which are coming before to the D block. So therefore D subshell is not filled up. Please remember. So D 5D 1. Fine. So that's where we have total 17 electrons. This will be the electronic configuration for lutetium. This will be the electronic configuration for lutetium. Fine. Can any one of you write electronic configuration for element having atomic number 64? Element having atomic number 64. Can any one of you write element having atomic number 64? That is gadolinium. Okay, GD 64. Can any one of you write? This is 4f block element only, inner transition element, lanthanoid series. So we have to take xenon. Then, what is next? What should be the electronic configuration for GD? Gadolinium. Okay, 6s2, 4f12, Shri Vidya. Okay. So we require 10 electron because 64, xenon is 54. So I will write 6s, 4f, 5d. Okay. Now 6s, yes, done. I will fill it up. Now what will be left over? Left over will be 8. Left over will be 8, Shri Vidya. Oh, she has deleted. Okay, fine. So 6s2, 4f8. Okay, fine. But what I will do is, it will take 4f7, 5d1. 4f7, 5d1. Instead of 4f8, all of you remember, instead of writing 4f8, you people are absolutely correct. Because you people are based on Aufbau principle, you people are writing the electronic configuration. But you are forgetting stability. Stable outer electronic configuration. Elements will going to prefer stable outermost electronic configuration. So therefore, instead of making 4f8, element will push one electron to 5d so that it can have the half filled electronic configuration with respect to F subshell. Half filled. Right? So due to that, it will be quite stable. I am talking with respect to F subshell. It is going for half filled because F subshell can accommodate 14 electrons. Half of that one will be 7. Absolutely correct, Darshan. Fine. So therefore, this is where we have some of the electronic configuration which will not exactly follow Aufbau principle. That is because of the stable electronic configuration. It wants to have the stable electronic configuration. All of you have understood? Fine. So in that case, can you tell me what should be the general electronic configuration? What could be the general electronic configuration for F block element, that is inner transition elements? What can be the general electronic configuration, that is outer electronic configuration. It can be n minus 2 f 1 to 40, right? Then comes n minus 1 d, n minus 1 d. So how many electron I can accommodate here? How many electron? It can be 0 to 2. It can be 0 to 2. Then comes the ns2. Then comes the ns2. All of you have understood? So this can be the general electronic configuration for inner transition elements. Only outer electronic configuration, that's very important. This is the general outer electronic configuration for inner transition elements or F block elements. All of you have understood? Fine. Okay. So this is where we have the general outer electronic configuration. Now, what we have discussed here is that is with related to features of F block elements. We have discussed about the features of F block elements. Now, what is the another name? Another name here is inner transition elements. Another name here is inner transition elements. Why they are called as inner transition? Because in these elements there will be filling of inner energy level, not penultimate, even inner to penultimate energy level which is getting filled up. So therefore they are called as inner transition elements. And there are two types. One is 4F inner transition elements and another is 5F. Fine. Now 4F can be called as lanthanoid series. They are called as lanthanoid series. And 5F they can be called as actinoid series. Right? So why they are called as lanthanoid series? Because they will be starting or they will be after lanthanum. Right? They will be along with the lanthanum. They will initiate with the lanthanum. Why they are called as actinoid? Because they will initiate with the actinium. So that's where we have the lanthanoid series and actinoid series. So lanthanoid series starts from cerium, or I can include even lanthanum also. Cerium to lutetium. So here thorium to lauresium. I am getting LO only. So LR it should be. Okay na? So LR, lauresium. So that's where we have the two series. Now, very important point here is, when it comes to actinoid series, they are radioactive in nature. They are radioactive in nature. Fine. So what do you mean by radioactivity? Radioactivity means these are the elements which will attain the stability in their nucleus by emitting the radiation, which will try to attain the stability with respect to their nucleus, and during that time they will be emitting the radiation. So those elements are called as radioactive elements. If you want to have, we have uranium, which is the best example for actinoid series. We have the uranium, and those elements which comes after the uranium, all of them are called as uranium. Yes, it should be uranium. I am talking about uranium. Okay, so this is one of the radioactive element all of you have studied, right? So that's where actinoid series are nothing but uranium is one of the example where radioactive elements will be the one which will be present in actinoid series, and those elements which will be after the uranium can be called as transuranium elements. They can be called as transuranium elements. So what are transuranium elements? These are the elements which are present after the uranium in the actinoid shells. In the actinoid shells. All of you have understood? Fine. So these are some of the points related to F block elements. These are the some of the points related to F block elements. So one thing you should remember that in the periodic table, actinoid series is the one which will be having radioactive elements, and along with that almost 7th period elements, even with respect to P block also I am telling, 7th period elements will be radioactive in nature, or lower elements will be radioactive in nature, most of them, right? So that is because they want to have the stability. They don't have the ratio of unity with respect to nucleus, neutron and proton in the nucleus. So therefore, to have the ratio to become 1:1, they will be emitting the radiation, ratio of neutron and proton. So during that process, they are going to emit the radiation. All of you have understood? So that's where we have the inner transition elements. Any doubts? Okay? Any doubts? So that's where we have done with the 3.3 and 3.5. Explanation about the periodic table and explanation about the S block, P block, D block and F block. So we have done with 3.3 and 3.5. Fine? Now, this is very important. Whatever I will be telling, this will be very important, because from here many times they have asked for 1 mark. So that is related to naming the element having atomic number greater than 100. So what I mean to tell you is, we are talking about IUPAC nomenclature. We are talking about IUPAC nomenclature. Fine? Say for example, if you have 0, in this case we will consider it as name. We will consider it as name. If it is 1, then we will call it as un. Okay, if it is 2, we will call it as bi. Okay, so if it is 3, we will call it as tri. If it is 4, we will call it as quad. Okay, na? So we will call it as quad. If it is 5, we will call it as pent. So like that, list will go on. If it is 5, we will call it as pent. If it is 6, we will call it as hex. If it is 7, we will call it as hept. Like that, oct for 8. Okay, fine. So that's where we have the naming of the elements. Okay, naming of the elements. So anyway, I will write it here. 8, it will be oct. 9, it will be n. Okay, 10 nothing. So that's where we have the naming of the elements. All of you have understood? Fine. Is the board visible? Okay. Oh, once again problem is that for all of you board is visible. Madam is asking whether board is visible. Okay. Fine. So that's where we have the 0, nil, 1 un, 2 bi, 3 tri, 4 quad, 5 pent, 6 hex, 7 hept, 8 oct, 9 n. So these things you should remember. If you practice with 1 or 2 times, it will be easy. Okay. See, for example, I have atomic number element with atomic number 101. I am not talking about the writing the electronic configuration. That one we know. We will take the help of radon and we will write the electronic configuration. I am talking about IUPAC nomenclature, naming of these elements. Fine. See, what is there in 101? First one is 1. That means I should talk about un. right? So after 1, what is there? 0. What is that? 0 is called as nil, right? Once again, 1 is there. 1 is done and 0 is nil, and once again 1 is there. That means un. So I will write it as un-nil unium. Un-nil unium. So at the end, um should be there. That's what. At the end, should be there. Un-nil unium. Some students, they will write un-nil un. No, this is wrong. It's not a complete name of the molecule. Always you should end up with Okay? So un-nil unium. So that should be the name of atomic number, element with atomic number 101. Right? There are general names. They have given the name, like to credit the scientist, to give to this one, to credit the scientist for their contribution, like 101 element will be called as mendelevium. Okay, so to credit Mendeleev's contribution. Okay, to credit Mendeleev's contribution. So that's where we have the un-nil unium will be the IUPAC name. Right? Along with that, Mendelevium, that is also fine. Okay, Mendelevium, that is also fine. But un-nil unium you should write. All of you have understood? So in that case, what can be the name of the element with atomic number 110? With atomic number 110. Okay, so this name, that un-nil, un and all, that is based on the Greek, this one. So based on that, they have given the name. Okay, because what will happen here is, in some of the countries, they want to contribute to their scientist, and some other countries they want to contribute to their scientist. So to avoid all this confusion, they have given the name of these things, to have the uniformity all over the world, to have the uniformity. Fine. So that's where we have the un-nil unium. Like that. These are the abbreviations for the integers, to maintain the uniformity. That's all. Fine. Now what should be the name? Or someone had written un-nilium. Un-nilium. Yes, absolutely correct. So now if you remember the name of this element, it's based on the Roentgen, another person who worked on radioactivity and all. Right? So that's why based on his name, the name of this element has been given. Right? Roentgenium. Like that they have given the name. But this will be the IUPAC name. 1 mark question you can expect. Right? So what we will do is, what should be the name of 180? What should be the name of element with 180? Hmm? 180. It will be octium. An octium. Right? So that's where we have the name of the molecule. Very good. That's where we have the naming of the elements which is having atomic number more than 100. So what you can do here is, what you can remember here is 2. Normally for 2, people go with di. They will go with the di. That's where they will make the mistake. It's not di, this is bi. Right? So nil, that is 0. Un, you should remember. Bi, but rest of the things, It is very oftenly people are going to discuss, right? For example, for 3, triad. Already we have discussed triad, right? So same way, octaves, law of octaves, 8, oct. Like that, some of the things we have oftenly read this one earlier, right? But that's where 2 instead of die it will be by, and 1 it will be un. Not as mono, it will be un. So these are the some of the things which you have to remember. Fine? Any doubts? Because now I am going to 3.6 because 3.4 is also done. What I have discussed is 3.4, even that is done. Any doubts up to here? For all of you, any doubts? Otherwise, I will move to the next concept, that is 3.6. Fine. Now, when it comes to elements, we have to talk about some of the properties. We have to talk about some of the properties. I am not talking about chemical properties. I am not talking about physical properties. I am talking about those things which are going to decide these properties of the element. Whether I am clear? I am talking about those properties which are going to decide the chemical property or physical properties of these elements. How exactly these elements are distributed in the periodic table with respect to their atomic number, with respect to their outer electronic configuration, everything already we have understood. We have already studied how exactly elements are arranged. But here we are talking about some of the properties which will be like ionization enthalpy, electron gain enthalpy, metallic character, non-metallic character, electronegativity, electropositivity. So these are some of the points or properties which are interrelated to each other. These are some of the properties which are interrelated to each other. Right? For example, if I am telling metals, all of you will agree with me that in the periodic table metals are dominating. In the periodic table metals are dominating. So S block elements, then D block elements, F block elements, they are all metals. But when it comes to P block, where we have the non-metals which will be dominating, but even there also we have some of the metals. Right? So what I mean to tell you is, in a periodic table, metals are dominating with respect to the number. Metals are dominating with respect to the number. That is one thing, one point which you have to remember. Fine? So next one here is, when I am talking about the period. When I am talking about the period. Now what is happening? Here, for example, when I am talking about period number 2, I can see there will be presence of outermost energy level as 2. Outermost energy level as 2. Now, that will be going on like this. In all these elements, outermost energy level will be 2 only. All of you will agree? In all this, outermost energy level will be 2 only. That's where period number 2 indicates. What about period number 3? Period number 3 indicates that where all the elements will be outermost energy level will be 3. Right? So what I mean to tell here is, when I am talking about the period in the periodic table, which is horizontal row in the periodic table, where electrons will be entering into. Electrons will be entering to same energy level. Entering to same energy level. All of you will agree? When I am talking about the period, electrons, try to understand these things. Fine. So if you understand these some of the points, then you can answer anything in the periodic table topic, that is classification of elements topic. Fine. So in the period, electrons will be entering into the same energy level. So what I mean to tell you is, if I take lithium, so that's where I have the lithium, beryllium, then boron, then carbon, nitrogen, oxygen, fluorine. I have omitted inert gas. Fine. So that's where we have the elements. So I can tell lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So this is how it will be there. In all these cases, electrons will be entering into energy level 2. Right? Energy level 2. All of you will agree? Fine. All of you have understood what I mean to tell you is, when I am talking about period, electrons will be entering into same energy level. Period number 2, it will be energy level 2. Period 3, it will be energy level 3. Like that, it is in the same period it will be entering. But if you observe it carefully, what is happening? There is a decrease in the atomic size. There is a decrease in the atomic size, right? Or atomic radius. There is a decrease in the atomic radius. Why? What is happening? Why along the period atomic radius has to decrease? The answer is very simple. That is because if I observe it carefully, atomic number is 3, 4, 5, 6, 7, 8, 9. Atomic number is getting increased. Along the period, atomic number is getting increased by one number. Now what I mean to tell you is, when there is increase in the atomic number, that shows that increase in the number of protons. So increase in the number of protons, right? So what is the charge on the proton? Positive charge. There is a presence of positive charge on the proton. So due to that, it will give nucleus a positive charge. Where protons are present? Protons are present in the nucleus. Since protons are present in the nucleus, since neutrons does not have any charge, what should be the charge of the nucleus? Positive. Net charge of the nucleus should be positive. Now I have the positive charge and I have the electrons which are negatively charged. So therefore, that's where we have the nuclear force. That's where we have the nuclear force, right? So due to the positive charge in the nucleus and because of electrons which are having negative charge, there will be presence of nuclear force acting on the electrons. Positive, negative, they will be attracting. So that's where we have the nuclear force, which we will call it as nuclear force. Now, since we are increasing the number of protons, as we are moving across the period, since we are increasing the number of protons, that means we are increasing the positivity of the nucleus. We are increasing the positivity of the nucleus. Now, at the same time, electrons are entered to the same energy level. Electrons are entered to the same energy level. So, due to that, what will happen? More amount of positive charge will be acting on the electrons, which are in the same energy level, because we are adding electrons to the same energy level. So due to that, there will be contraction of outermost energy level will take place. Contraction of outermost energy level will take place. Now the answer is very simple. Why across the period atomic size will decrease in the periodic table? The answer is, across the periodic table, electrons will be entering into the same energy level. Since there is an increase in the nuclear charge, due to that there will be decrease in the atomic size. All of you have understood? Any doubts? Now what is happening? Along the period, electrons will be entering into the same energy level, and once again there is an increase in the proton also. As there is an increase in the electron, naturally there should be increase in the protons because atoms are neutral. So due to that, what is happening? At the same time, there is an increase in the nuclear charge along the period. Due to the increase in the nuclear charge, and once again, since electrons are entering into the same energy level, naturally it's going to decrease the atomic radius. Yes, Achyuta, that one I will come to that. All of you have understood? Any doubts? Why there is a decrease in the atomic size? So now, if I go here, I have lithium, sodium, potassium, rubidium, cesium and francium. Right? That's where I have the element. Hydrogen I have not written because I have started from period number 2. So lithium, sodium, potassium, rubidium, cesium and francium. So these are the elements. Fine. Now, when I am talking about lithium, period number 2, period number 3, so period number 4, so period number 5, so period number 6, then finally we have the period number 7. So what is this period number indicates? Energy level. So when I am talking about lithium, 2 energy levels are there. Okay, so here I will write, so period number 3, right? Then comes the period number 4, then comes the period number 5, then I stop here, period number 6, 6. So that's what I mean to tell you is, this is outermost energy level, period number 3. Outermost energy level it is 4, therefore period number 4. Outermost energy level it is 5, therefore period number 5. Then comes the period number 6 where outermost energy level is 6. Okay, so period number 7 it's not there because lack of space. Okay now, so that's where I have the elements. So period number 2, period number 3, period number 4, period number 5, period number 6. If I take period number 1, that will be the 1. Period number 1, I am talking about hydrogen. I am talking about hydrogen. So what I mean to tell here is, when I am moving down the group, so down the group, what is happening? Atomic radius is increasing. Atomic radius is increasing. When I am moving down the group, atomic radius is increasing. So what it means? Why atomic radius should increase? Many students they will get confused. Along the period, down the group, many students they will get confused. Yes, Shri Vidya and even Mansi, absolutely correct. Down the group, there will be increasing in the atomic radius. Why the hell? Question is, why the hell there should be increasing in the atomic radius? Because when I am talking about atomic number, there will be drastic increasing in the atomic number. Because lithium 3, if I talk about sodium, it became 11. Because I have to add 8. If I talk about potassium, it will become 19. I am adding 8. Now I should add 18 to next element. Right? So I have to add 18, that is rubidium. I have to add 18. So 19 plus 18, how much it will be? So that is 37. Yes or no? So what is happening? Along the period there was increasing in one proton, but down the group there is a drastic increasing in the number of protons. But as Manvi, she has written, that is, there will be increasing in the atomic radius. That is because when I am moving down the group, every time there is increasing in the number of period. Right? So that indicates that when I am moving down the group, I am moving to the next energy level. I am not in the same energy level. I am moving to the next energy level. That means when I am moving from lithium to sodium. Now, in lithium, outermost energy level is 2, but in the sodium, outermost energy level is 3. And due to that, lithium belongs to period 2, sodium belongs to period 3. When I am moving from sodium to potassium, that means in sodium, outermost energy level is 3, but in potassium, outermost energy level is 4. Therefore, potassium belongs to period number 4. Same logic when it comes to rubidium. Outermost energy level is 5, that's why it belongs to period number 5. Cesium, period number 6, because outermost energy level will be 6. Francium, outermost energy level will be 7. So what I mean to tell here is, when I am moving down the group, I am moving to the next energy level. Right? That means electrons are not entering into the same energy level. The electrons are entering into next energy level. So therefore, there should be increasing in the atomic radius. Although there is increasing in the number of protons, since we are moving to the next energy level, we are in the sense electrons. Electrons are entering into the next energy level, there will be increasing in the atomic radius. Right? So electrons will be filling to next energy level. So due to that, there will be increasing in the atomic radius. But along the period, it will be in the same energy level, electrons will be entering. But here, electrons will be entering into the next energy level. So due to that, there will be increasing in the atomic radius. All of you have understood? Any doubts? So you people have to remember these concepts. If you remember these points, the whole story can be explained. The whole story. Ionization enthalpy, electron gain enthalpy, metallic character, electropositivity, electronegativity, non-metallic character, everything can be explained if you understand only these two. Right? So what you can remember here is, because I will be stopping here, so what you can remember here is, along the period, there will be decreasing in the atomic size, although there is increasing in the atomic number, there will be decreasing in the atomic radius, but down the group, there will be increasing in the atomic number. At the same time, there will be increasing in the atomic radius also. What is the reason? Because when I am talking about the periods, electrons will be entering into same energy level. Due to that, due to increasing in the number of protons, that means nuclear charge, there will be contraction of atomic orbital will take place. But when I am moving down the group, electrons will be entering into next energy level, and due to that, there will be increasing in the atomic radius or atomic size. Fine? Any doubts in today's class? Any doubts? Okay. So in that case, I will stop here. Tomorrow we are going to continue, and tomorrow I think we can finish it off. this particular topic. Okay, fine. Thank you. Take care then. Bye. Thank you everyone.